Okay, good morning and welcome to this fourth episode of the DHC Plus Innovator webinar series where we showcase the best innovation in our industry. My name is Gabriele Pesce. I'm the Director for Innovation and Sustainable Finance Europe and Power, the International Association for District Heating and Cooling. I also coordinate the DSC Plus platform, the R&D branch of Europe and Power. Today, we have two hosts, Xiaofang Xu and Julie Godefroy from Harup. And basically, we are, sorry, I cannot you. Sorry, I have a problem in my computer. Just a second. Marietta, I can, my Zoom is having problems. Sorry. Today is not a, okay, it's working again. Sorry very much. So today, repeating, so I hope you could hear me so far. So today we are presenting a model evaluating embodied carbon heat project, heat network projects presented by Arup and Julie Godefroy. Before I have a more technical problem, I would prefer to give the floor to Xiaofeng Su to present the project. And sorry for these technical bumps. I hope to solve soon. Xiaofeng, the floor is yours. Sorry.
Thank you, Gabriel. And I'm very happy to have Julie join today so I'm introducing yourself from SIPSI, and I am a principal energy engineer working for Arup. So today, like Gabriel mentioned, we're going to present a journey of how we're evaluating embodied carbon and heat network projects. I will start from a brief introduction about Arup for those who don't know the company, and a little bit about myself, what we do, and our initiative and commitment on whole life carbon assessment, and also a couple of projects we delivered in the past, and also some reflections from project delivery from the partnership we're working on that we'll introduce a little bit later. And very keen to hear your feedback and comments and questions later. So this is presenting the company. So we're an independent firm consisting of designers, planners, engineers. In the past, we are very focused on building sites from civils to mechanical or engineering services. But in recent, what I would say, decades, we're very much focused on energy as well. We have 95 offices and across 34 countries, and you can see the red dots there across Europe and the UK. Our headquarters based in London, which is where I am now. And about the company, I sit in the energy portfolio. My specialists or expertise lands in district heating and cooling across design, policy, planning, funding, delivery. Also interface with a number of power infrastructures and also linked to energy strategy, transactions, technical DD, spatial energy system modeling, like whole energy system modeling, local area energy plan, also assets, price scenarios. The team is quite widely kind of spans different specialism and working closely with the other energy teams that you can see from the screen. I'll keep it short so that you don't get bored. I'm going to the embodied carbon topic. So in 2022, we developed our carbon reduction targets and adopted our net zero carbon strategy, which you can see on the right-hand side, including covering scope 1, 2, 3, and also within the company, we have been actively developing a number of platforms, databases, toolkit to support whole life carbon analysis for across the projects we are working on. We also have committed to work on renewable projects such as hydropower, solar, wind across the projects, which is where I sit in. And I don't know how many of you have heard of PASS 2080. Arup was involved in the original authorship for the 2016 publication and also led the revision version that was published in 2023. This is more like a whole life carbon management plan to guide the projects how and programs in the building environments about how project can be about how the project can be can conduct whole life carbon assessment, how the design decision at early stage could influence the whole life carbon, and how to incorporate. What's more important is how to incorporate decision making with the embodied carbon whole life carbon assessment at early stage. This is probably the meaty bit I wanted to show. I do want to set the context is over the past years, we have been trying to apply whole life carbon assessment on heat network renewable projects we have worked on, and there are a number of challenges and questions has occurred during the assessment, and which is why we now are working in partnership with the Carbon Trust to support CIPSI in developing a whole evaluation, a whole methodology, standardized methodology for evaluating embodied carbon in heat networks, which Julie is going to introduce in more detail later on. And I will quickly go through the project's output here and a bit of thinking of how we deliver the project evaluation and what challenges. So on the right-hand side, you can see 3 scenarios we delivered, and scenario 1 is for building level electrification, air source heat pump LED system plus electric boiler on top, and the whole life carbon evaluation on the left 2 columns. And scenario 2, we modeled a mixture of cluster heating and plus building level electrification, basically a mixture of technologies and energy supply systems combined of air source heat pump LED building system, and also a district heating network where heat recovery is achievable through the cooling system. And scenario 3 is a full district heating network supplied by a spine network to all the buildings with on-site top-up. I think one of the drivers to conduct such district heating network, originally it came up about incorporating embodied carbon on top of the operational carbon, because it's known that if a district heating network has high efficiency, has heat recovery, you should have lower, technically speaking, you should have lower operational carbon because of all the optimized performance. An argument we had in the industry is, what about embodied carbon for the additional infrastructure of the pipeworks, and how does that incorporate it into the whole life carbon? And also for the commitment we mentioned about conducting whole life carbon and also to gather all the database. So we started this assessment, and the results is, back then, it was a couple of years ago, was slightly surprising because it's, as you can see from the results, it's not that straightforward saying, oh, scenario 1 is the best or scenario 3 is the best. We tested different scenarios using different global warming potential refrigerants, using different strategies. Obviously, the strategy was set for the specific projects. It's not fixed saying this is the certain resilience, and also how the resilience works or influence whole life carbon assessment. The great bits we can see for building level system, your whole life carbon assessment, your whole life carbon emissions are very much influenced by the resilience because of the need to ensure the individual building level system works, and the individual backup needed for individual buildings. For the mixture of cluster heating and for the full district heating network, it's less straightforward because it does kind of rely on the design philosophy that you're putting forward, whether how much heat you've recovered from the cooling system. But what's obvious is the resilience needed, or the percentage of your resilient system accounted for whole life carbon is lower. And another interesting finding we had is how the additional infrastructure offsets the embodied carbon emission from the equipment, such as heat pumps, because of the resilience. And those are the findings back then. I think back to some of the challenges we had is, especially on the distribution side, we worked with infrastructure decarbonization team, but to some extent we have methodologies developed for building side, and we have the carbon framework, management framework guided for the infrastructure projects. What we have found is district heating network is quite a unique piece because it connects to the building elements, and it has the generation aspects, and through an infrastructure that serves or quite specific for the purpose of leveraging the low carbon source to the building heating demands. I know we have some lessons learned from the hydrogen from different infrastructure, and trying to incorporate those lessons. So yeah, this is the first projects we delivered. Quite interesting. Bear with me. This is another project we did for renewables, because there's back then it was quite interesting discussion about how the battery energy storage combined with the heat, the PV, and to serve the total demand, including heating and cooling on the building side, and how the source impacts the overall embodied carbon. It has the different hierarchy included in this case study, obviously, because it's not only the technology testing, it also incorporated a quite number of demand reduction to reduce the operational carbon, and also different on-site regenerative natural ventilation to minimize the demand to begin with. And on-site renewable generation has a number of non-renewable technologies to ensure the power cuts, because it's not in the UK. Again, the red bits is the kind of the operational electricity or the diesel generator operation carbon, and embodied carbon for PV and for the battery combination is on the right two sides. And it is, again, quite interesting about how the influence from your savings from PV panels, as in you're avoiding use of the electricity or the power, but how the embodied carbon or whole life carbon is influencing the total carbon emissions. And those are a couple of key takeaways. It's not only from those projects. I don't know how many of you attended the recent webinar that we hosted, and Julie did a presentation about the TM65 methodology, and also a number of interesting questions raised by the audience. And we're hoping to gather your feedback today and what's happening in Europe, and especially for the upcoming heat and cooling strategies. How do you see embodied carbon fit into the whole life carbon, or compared to the operational carbon assessment? I think the top one that we had is heat networks must be evaluated as a system, not the products. We have comments from heat network operators or the industry about how the current embodied carbon is compared between a heat network option offered connection to building that is naturally comparing the heat network connection to a heat pump, which from certain aspects it's kind of unfair for how the systems were compared. So one of the elements we're working on is make sure the boundary of a heat network is standardized and a fair comparison across the energy systems. And collaboration across the industry is essential. We have carbon specialists, we have building service specialists, we have grid specialists, and we also have heat network specialists, and how to promote a fair comparison and also for an integrated energy system from a macro level is critical for the whole life carbon assessments. And also the methodology must be enable the decision making rather than another kind of admin topic to report your embodied carbon. And the past 2018 I mentioned very emphasized how to incorporate whole life carbon assessment in early stages rather than at the detailed design stage where you would have limited influence on the design, and how the early stage assessment could influence the design decision and to ensure the lowest carbon solutions. And I'll end up here about the TM65 HE network, how we aim to fill a critical data gap from all the challenges we presented. And I'll hand over to Julie to talk about the TM65 family and about the work we're working together.
Thank you very much. Can you hear me?
Yes, we can.
Can you hear me? Yeah. Yeah, great, thank you. So I'm Julie Godefroy from CIBSE, which is the Chartered Institution of Building Services Engineers, and I'll present a bit of the work on embodied carbon in general, and then zooming in on what we're doing with Arup and the Carbon Trust on heat networks. So the work on embodied carbon started a few years ago with the TM65 methodology. TM is Technical Memorandum. And it was in 2021 that we essentially published this guidance, which provides 2 levels of assessment for embodied carbon of MEP products, so mechanical, electrical, and plumbing products, where EPDs, environmental product declarations, are not available. We were hearing quite a lot of engineers who are starting to pay attention to the embodied carbon of their design, but there was very, very little information at that point. And we thought that an estimated methodology would be useful. The methodology is provided at 2 levels. One is the one we call basic, which really is very basic. It's basically the weight of the product, what material it is, and then there's sets of assumptions about where it was made from. If there is refrigerant, you also have to say roughly the charge and the GWP, but it is very, very basic with all sorts of other assumptions for you if you can't get that information from the manufacturer. And then there is a mid-level calculation with more information on where the product was made and various components, but again, very much simplified compared to an EPD. More recently, about a year ago, we also started to produce verification, and quite a lot of manufacturers are interested in getting their products verified through that, but the bulk of the calculations are still made by a range of disciplines, whether it's contractors, design consultants, or manufacturers, and it's what we call self-assessed, so there is no verification. All of this, though, was only the start from us. The ultimate aim at CIBSE is that we want to equip engineers to design for low whole life carbon. So in order to do that, we want to equip engineers with embodied carbon just as they are on energy use, which means ultimately for them to have benchmarks and rules of thumbs on different buildings and system situations. We want them to be aware of key design decision and to have that sort of instinct of impact and of key decisions needed at the early design stages, just as they are on energy when they're comparing, for example, natural ventilation and mechanical ventilation systems, or heat pump versus boilers. All of these tools, benchmarks, key design decisions, instinct, they already exist on the energy side, and we want to be able to add embodied carbon to that. we're quite keen for that to happen at the early stage, which is why also there is a lot of interest in TM65. It's not only that it's simpler, but it means that you can do an estimate of a design at the early stages. You might actually not know what your product is. You probably don't know what your product will be, but you could do something reasonably generic and test options in that way much more simply than you would through EPDs at the detailed design stage. So it all started with TM65 at the product level, and we have now moved on to producing systems, additional guidance on TM65 systems, which means that product is only the very small part. And even if we were to compare to EPDs for products, it might not be comparable because one of them might have included, for example, controls or storage integrated into the product, while the other one doesn't. So we're very keen for comparisons to be on the systems basis. And we have started that with a series of publications, residential heating, lighting, logistics centers, commercial HVAC last year, and now we're starting on district heating. At the same time, we're also starting to make use of our product level data. So creating a database, we're moving on to an online calculator, which will have much more functionality for us and for people who use TM65 calculations. The aim is that we would create generic data points or benchmarks basically at the product level. And then gradually, in order to reach that goal of designing for low whole life carbon, probably we will produce MEP whole building benchmark. So what is an average and say best practice level of MEP embodied carbon in say a residential heating scheme or in an office, etc. To give engineers an idea about that sort of embodied carbon budget and where their project fits against this, and working back maybe benchmarks for MEP systems, all of that with the aim of influencing early MEP design. That's where TM65 heat networks sit. And I'll tell you a bit more about, excuse me, there's a delay on the slide, sorry. I'll tell you a bit more about TM65.1, which was on residential heating. So that's one where we've compared the embodied carbon impact of residential heating systems in various options, which means we've gathered already quite a lot of data on residential heating at the building level. You can see here a comparison between various heat pump and VRF and direct electric heating configurations, as well as the last one, which was district heating, which we applied to one of the case studies. However, that comparison that you see here was very much not including the whole network. It included the embodied carbon impact of the pipework of up to the point of connection, but it did not include the embodied carbon of the district heating scheme itself, so the energy center and the distribution pipework. And that's basically where this new TM that we're working on with Arup and the Carbon Trust is picking up. So the network itself, pipework distribution, etc., and the energy center. It's quite important because the UK is about to embark on potentially quite a significant program of heat networks, both new and expanded schemes. And there will be much more regulation of these networks on their operational impacts, but also many more incentives. And at the moment, there is very little data, especially data in the public domain, on the embodied carbon impact. An important reference in the UK is the whole life carbon assessment methodology from RICS, which is based on EU standard, but which provides much more detailed guidance specific to the built environment. And there is basically one reference saying, well, if you don't know what the embodied carbon impact of your district heating network is, you can use this value, which is actually an EPD from a European scheme. It's not even a network based in the UK. So there is very little data widely available at the moment to engineers and to policymakers to estimate this. And the key questions were at the start, so it's a very good time to speak to you all if you have ideas, suggestions, etc. The key questions we've started to tackle, or I should be fair, Arup and the Carbon Trust have started to tackle with our steering group, is the main one is what should be a consistent and fair basis for comparison. So comparison between networks and/or comparison between networks and on-site solutions. And for that, it means where do we put our system boundary? So what do we include or not in the assessment? I think we've got reasonable consensus at the moment on a lot of what's going on in the energy center and the pipework, etc. But for example, there are still discussions about how we consider or not the wider system. It's very interesting already that we've heard from Shafang about resilience, because one of the arguments that we're starting to hear now is that heat networks can reduce pressure on the electrical networks. Do we start to account for that within our system boundary, or do we include it more as a qualitative note but do not include it in the calculation? We're more minded for the second one. So it would not be included in the system boundary, but then it has to be mentioned at least as a qualitative outside the boundary consideration. Another important parameter, obviously, to establish a fair comparison is what our functional unit is. So how do we declare the embodied carbon of the network? There's many options. It could be embodied carbon per kilowatt hours per year generated or delivered to end users. Or it could be in peak generated or delivered. We're probably at the moment minded to use a combination of metric with some for reporting, but majoring on kilowatt hours per year generated or delivered. Let's see. But more on an annual basis at the moment. I'd be very interested in views on this. Then the next big question in this guidance is how can the guidance best support engineering decisions for low carbon design? So which elements are the most influential to assess and to address? We will be in the guidance providing examples or case studies of various options. Helping engineers already understand what are the key elements where most of the embodied carbon is, but also there is the most potential to reduce that embodied carbon is important. And which leads us to what are the main options in terms of network typologies and design details which are relevant to address and to compare in the guidance. It will only be an initial comparison, but to start to give engineers that instinct and that awareness of key decisions is important. So again, any advice or thoughts on that would be very welcome. I'm going to wrap up now, but basically we would be very keen to hear from all of you. There's probably a lot of experience in Europe that we could build on and incorporate in our guidance. You've heard what our key questions are. What do you think are parameters for a fair comparison? And what are the key decisions that engineers need to have guidance on? Because at the moment, maybe there's no consensus, or you see a lot of bad decisions going on and you think that needs to be addressed. And we would be absolutely delighted to get your case studies and data, whether it's on whole networks or on elements. So do contact us if you have anything to contribute. It can be on an anonymous basis. If you want to find out more about the TM65 work in general, we have a dedicated webpage to it. You will see that We're working not only on systems, but also around the world. So the methodology has been adapted for quite a lot of countries and regions around the world. And we also have an embodied carbon working group. Here are my contact details, and thank you very much for your time.
Thank you, Julie. Thank you, Xiaofan. Sorry again for the bumps in the introduction. My laptop now is still alive. Absolutely. Maybe because of the bumps, I couldn't say that the webinar is recorded, and I really invite people to post questions through the Q&A box at the bottom of your screen in the Zoom application. But this time we also have some questions from the guests. So maybe it would be nice, Julie or Marita, could you go back to the key question slide? Maybe while we are waiting for some questions from the audience, if people are willing to give their feedback to Julie, they are more than welcome right now. Otherwise, you will have time to contact her or Xiaofang directly by mail and give your feedback. Of course, it's not an easy. I understand it's not an easy question to reply at the moment, but of course, you are more than welcome. In the meanwhile, I have some questions. So again, I really invite you also to put some question concerning the slide, not just the key question of the Julie presentation. So feel free to do it. I will read it for you. The questions are addressed to you both, so feel free to decide who's wanna reply. My first question concerns the operational and embodied carbon trade-off. So we say that heat networks are often justified primarily on operational carbon savings. In your experience or through your studies analysis, how often do projects actually risk increasing total life cycle emission when embodied carbon is properly accounted for? Is it clear, my question? I know.
Yeah. Do you want to start or?
No, go ahead. I can join you afterwards.
Thank you. So I have not seen detailed case studies. Today's was the first, so you're quite lucky. I think there's two things. At the moment, we don't really know. That's the whole reason why we're starting this TM65 guidance, because there is very little data available. I would say that what we hear, so what we've heard today from Arab and what I have heard anecdotally from others, is that probably once everything is accounted for, the embodied carbon of heat networks is more than we think, because that's always the case. When you count embodied carbon, you always find out that it's more than you thought. But also that maybe it's not so drastic, the difference with on-site systems. And it is quite dependent on your particular project. I was really interested in the way that the results today were presented to highlight that resilience impact, because very often I think embodied carbon of MEP is presented as here's a heating plant, here's pipework, and I think differentiating between what's backup and the rest is very interesting. I think that would be quite a trigger in many designs to reconsider what you've done. What I would like to say, though, is that I think at the moment, the main question on heat networks is also what operational carbon savings they offer. And we do have in the UK a legacy of networks that run on gas. So they do not necessarily offer operational carbon savings, let alone embodied carbon savings. I suspect the rest will really be very case dependent. If we're talking about heat network in a completely new neighborhood where everything has been well planned, it's very different from implementing a heat network in an existing dense city with all the works and inefficiencies that implies, everything that needs to be implemented in the existing building, etc. So I suspect it will be quite case dependent, but I don't know.
Thank you, Julia. I kind of briefly mentioned during the case study how the driver for the whole life carbon assessment, and I kind of see this question from a different angle because we're talking about operational carbon. It's about have we accounted for embodied carbon or the whole life carbon for the upcoming policy, for the upcoming fundings, or all sorts of topics. The whole world is going through an energy transition, and how do we what's the best for the future is a very key topics, and we keep talking about system efficiencies, but there is a broader picture out there. So we're doing embodied carbon evaluate or whole life carbon for the grid upgrades. We are working on renewables, offshore renewables or onshore renewables. We're working on integrated system like heat network. We're talking about geothermal. There's so much things being talked about, but really they're not connected to some extent. I think embodied carbon or whole life carbon assessment is a way to connect operational carbon and embodied carbon together. So we're evaluating the system as a whole system, because we work a lot on the whole system modeling, and it comes naturally a question when you're talking about whole energy system. So Julie mentioned one of the key benefits for heat network is to elevate the stress on the grid. So the resilience is not only have an impact on the capital cost, it also has the capital impact on the whole embodied carbon for the products, for the system, to reduce the grid upgrade to the pressure, to minimize the plants from a centralized position. It has space. So we're trying to link up the elements together. So from my view, it's kind of less of trade-off. It's more about how do we develop a comprehensive system linking up different energy systems together. I mentioned that one of the teams are working on hydrogen gas pipe work. So, how do we compare a heat pump to hydrogen? Because you can't. But if we talk about whole life carbon, then all of a sudden the whole one energy system. One of the key reflection I didn't mention from the webinar we hosted last week actually is it's critical to taking into consideration of the embodied carbon emission from a grid, from a gas infrastructure. And that leads to the question again that Julie mentioned about the work we're working on is where's the boundary? How do you ensure fair system comparison? So a lot of the good work thinking out there, and I think this is a platform we would like to hear from you as well. What do you think? We are taking steps forward, and I've seen some really good boundary discussions happen with CIPC, with Carbon Trust, with the steering group, and hopefully that guidance will be published soon for further feedback, which I was thinking, do I want to share some of that? But I feel like it will be good to keep it as a surprise. At some point, it will be good to reconvene this in summer to demonstrate some of the work we have done in response to the questions we raised today.
Thank you, Xiaofang. In fact, concerning boundary, we have a comment from Mikko saying embodied carbon is very difficult to assess fairly. Easiest would be to set boundary at the building boundary, meaning that only a DC heating substation would be counted from the DC heating network. Boundaries need to be the same for all technologies. If DC heating grid comes into the calculation, then also electricity grid embodied emissions from production to consumption need to be included as well. I don't know, because my second question was related to the boundaries, but I think we already addressed this. So we should be put at the energy center, network pipes, connected buildings. I don't know if you have any other stuff to add. Otherwise, we can. Do you have a comment from what Mikko said, or?
I think personally, but again, this is still for discussion. I think if we set the boundary at the building, then it's not fair, because when we count the building, we count, say, the heat pump that is based in the building, and then we compare that with a district network situation where we ignore it. So I think somehow the boundary should be the functional boundary, not the physical one. So I would say instinctively the heat generation and what is used to distribute that heat to the end consumers. I would also like to clarify the second part of the comment, I think, and apologies if I didn't express it well, but when I mentioned the impact on the grids, it would actually have been probably a benefit to the network. So it would not be to count the grid, it would be to say, well, thanks to the network, we've improved the resilience of the system, and therefore there is less grid reinforcement needed, and that somehow gets accounted for. I don't think we will end up doing that because it's very complicated and probably quite speculative, but it was to generate discussion, which clearly it has. So.
And I think it's a really good comment and probably represents some of the work that has been involved. Julie mentioned the TM65 started with the building boundary, and there's a good publication on TM65 and TM65.1 to use case study to demonstrate that. And I guess the question is how we're moving forward. You know, the benchmarks published by the RICS at the moment is very, very high level, and there are lots of discussions being discussed. And I think to some extent it's a chicken and egg. There is a significant data gap, hence we can't compare them. But if we are all working across, you know, the topics about working across disciplines. Sorry, my mind just went blank. Working across sectors, and if we're all working towards targets, and we have benchmarks on the elements for building, we have benchmarks for heat network, we have benchmarked for electricity grids. It's not about including every infrastructural system or product within one assessment. It's about how do we establish the foundation or the baseline, or taking mini steps. You know, there's a lack of EPDs. Yes, that's the reality, but how do we start some of the benchmarks at early stage to ensure a fair comparison across different systems? Because one of the challenges the heat network operators encountered in the UK is they were challenged by the building owners saying, I got this heat pump with embodied carbon efficient of X, but your heat network taking into the whole consideration of the infrastructure, everything that's higher, hence I can't connect to your heat network. So to us, you know, that's from the policy perspective and from funding perspective, it's challenging to implement heat networks. So we're trying to establish the methodology, and that doesn't remove the need for the building level system, doesn't, you know, those separate work streams. So we just need to work together.
Thank you, Theo Frank. I don't see any other question for the moment, so I will go to my third question. But before, I would like to ask the technical support to go back to the slide with the key question. Marietta Tai, can you go back to the slide that Julie presented just, I think, a few before this one, so we can give the chance to the audience to see. Okay, while we're waiting technical support to change slides. So the presentation raises the question of what the current functional unit should be per kilowatt hour generated or delivered. So in your opinion, which metric do you believe best reflects the real climate performance of heat networks?
Very good question.
We're both
at the moment, so on embodied carbon, that I know of, there is no widely used metric. If we look at the operational impact, carbon content of heat is used, and that's in kilograms of carbon per kilowatt hour of heat delivered to the consumer or delivered to the building. That depends a bit, but it's not necessarily widely used at the moment. For example, there is talk of it being integrated in a significant piece of new policy in the UK, which would be heat zones. But we don't really know the details. Maybe some people around here know the detail. I don't yet know. They're not public. So I think it would make sense to use the same for embodied carbon. I think it would probably make sense if that was heat delivered to the substation of the building as opposed to the end consumer, because it becomes really complicated in terms of responsibilities, etc. otherwise. But kilograms of carbon per kilowatt of heat delivered is what we have used in the very recently published UK Net Zero Carbon Building Standard, which is not policy, which is an industry initiative, but ultimately that's what our working group recommended. And the limit on the operational carbon impact of networks that we set in that standard is by comparison with the carbon content of heat of on-site system to make sure that there's no detrimental operational carbon impact. But that's very much part of the perspective and it's not yet policy.
From an engineer perspective, putting my designer hats on, it's a very interesting topic because the reason we're laughing is that's kind of constantly being debated in the steering group meeting. Everyone is talking and sharing their opinions. And from engineer perspective, as a beginning starting point, we're adopting the quantity assurance, the cost evaluation methodology, because, how would you describe, I often received question about, how much does it cost for you to build up an office tower in London? How much does it cost you to indicate initial investment decisions? And when it's the bottom up, you talk about the pounds per, product level. You talk about pounds per kilowatt, the pound per meter squared, not meter, pound per meter pipework. It could go down to a lot of details. So we are working on heat network taxonomy and trying to break down adopting the quantity surveyor system. Obviously, it's very early stages. And I think as a starting point, like Julie mentioned, if we are thinking of benchmark, like how do we describe the pound per meter squared for building, we tend to say kilogram carbon per kilowatt hours or kilowatt peak might be the straightforward because that's how you describe a network. But obviously, it's a bottom up and associated with all the more comprehensive EPDs and product level. It's a live, I would say, it's a live debate.
Thank you, Sylvain. Thank you, Julie. We also have some question about design, but before I would like to touch upon the let's say data availability gap. TM65 was developed partly because EPDs are often unavailable for MEP's products, right? How big is the data gap today for heat network components such as pipes, substation, heat pumps? It's big ones. How much is relevant this gap?
Do you want to speak as someone who uses it, and then I'll tell you? Do you want to start with
Me,
your perspective as user?
That's very much my question. Actually, Julia, I reached out to you a couple of weeks ago about what data have we collected. I know CIPSI has an initiative I've got the name Carbon Collection Scheme, trying to work on this. And I know within Arab, we created a Zero platform that takes into kind of try to consolidate data we have developed by applying the past 2080 to all the building projects. I'm not expert to the Zero platform, I have to admit, but also what we realize is the data for the infrastructure itself, there's a major gap. I mean, within a building, we are started to gather a pretty good data. That's my understanding. Actually, I'm quite interested to learn that from CIPSI as well.
Yeah, I think you're right. And it was a very nice way to frame the question. I think You're quite right that for quite a lot of the components, we probably already have the data, whether it's from EPDs or from TM65 calculations. For example, heat pumps is one of the products for which we receive at CIBSE the most TM65 calculations. Probably because they're a bit complicated to do EPDs for, and there's so many on the market. All the manufacturers want to be able to publish their data and for engineers to use it. Very clearly, the infrastructure and all the works associated with it, that's going to be a gap. So anybody around here who has done any assessment on their scheme, do let us know. It might be that we should mine sources of data, such as, for example, BREEAM has had for many years, BREEAM and SQL, so the infrastructure equivalent, has had for many years requirements to monitor the energy use during construction works. So if we at least access that data, we could translate the energy use at the very least into part of the embodied carbon of the infrastructure works. I'm much less worried, but that's from my ignorant perspective. I'm much less worried about the pipework itself. I think that should be reasonably straightforward. There should be data for that, but more about the works associated with it.
Yeah, we talk about the hotspots, about the material itself is probably well captured, but how to take it into a consideration of excavation, transports for the infrastructure isn't kind of very deeply looked into, and the benchmarks for the non-material or non-products elements. My impression is we got quite a bit of support from manufacturers by taking initiative on providing the data because we had a couple of webinars in our office from manufacturers about the initiative on this, but how to enable the whole life cycle on the non-product aspects is one is location subjective, and two is the fuels. Yeah, I mean, I won't go into details, but that's general kind of question I had about how do we standardize this.
Thank you, Xiaofang. Exactly. So again, I would like to reiterate this call for feedback to the audience for Julie and Xiaofang. If you ever had any analysis, report, assessment, please feel free to speak up or contact directly our host. And yes, a comment from my colleague Oksana. So it's true that within Euriton Power we have a dedicated engineering and design working group. So where we provide platform for technical collaboration discussion. So I really, exactly, Xiaofang, it's for members. It's just taking this part and engage with the expert also. That working group could be very helpful.
I was planning to do that. I will do that after the session.
Absolutely. So you can contact my colleague Oksana or my colleague Martin. They chair and they coordinate this working group. Okay. So thank you, Oksana, for these comments. It's very important. Yes. Well, let's say your methodology support early design decisions, of course, we said, when detailed product formation is not yet available. How reliable are early stage estimates, and how much do results typically change later in the project? Justine.
So again, just from a CIBSE perspective, and then I will pass on the mic. So I think because it's early stage estimates, deliberately to exaggerate, the actual number doesn't matter so much, whether it's accurate or not. What matters is the comparison of your options. So are you making the right choice? At the moment, there, for sure, during the design, as we're saying, the more detailed design, the more you count carbon, and carbon is likely to increase. That's what we've seen, not specifically to MEP, but in embodied carbon assessment. There's a very nice graph in the UK that shows how the estimate increases throughout the detailed design stage the uncertainty bound reduces, but the estimate itself increases. From a TM65 perspective, what we are more interested in is whether the sort of philosophy is right. And that is that essentially, if you use the basic method, which is very basic, your embodied carbon estimate should be quite high. And it should be higher than if you use a medium level estimate, which itself should be higher than if you use an EPD. And that's in order to provide a bit of a safety buffer, but also to encourage gradually more and more information and more details. So it's to encourage people to use a more accurate data source to produce a more accurate calculation. And whenever we have been able to make that comparison, the principle stands. So we've always had basic calculations higher than medium, higher than EPDs. There seems to be one situation with very simple products where that is not always the case. And it would be one of the things that we review in the next, in the revision of TM65. Basically, we have buffer factors, and maybe for very simple products, we need to change a little bit these, but that's the core principle we're quite keen on.
I wanted to quote the cost method again. I know for the RICS, at concept level, we accounted for minus plus 50% resilience, and that percentage should gradually reduce alongside the projects. And I think embodied carbon to some capital carbon to some extent is quite similar to capital to that. And whether it's increasing and decreasing, and that's a driver for standardized methodology to make sure we have this kind of middle line and take into account of resilience out there. And from the TM65 key network projects we're working on, so RB is collating kind of the chapter we're looking at is the case study. At the moment, we are looking for existing projects rather than conceptual. What we're trying to look for existing projects to work backwards, because with the data gap, with the lack of standardized methodology, to some extent, we don't know the answer about how this, because we haven't pinned the middle line yet. That's my perspective. And if we can work backwards from existing heat network, to feed back to the initial methodology and start apply that methodology developed to new heat networks and to see how it was delivered. And once we have the full life cycle project loop, then that hopefully became clearer. I think the whole heat network industry, from the performance, from the heat loss, like it went through those cycles several times. And embodied carbon is we have loads of good experience out there that we're not starting from scratch. But the percentage-wise, it is new.
Thank you, Julie and Xiaofang. We almost run out of time, so maybe have still a couple of questions for you, maybe less technical, more like broader. My next question is about the risk of methodological fragmentation, let's say. So, of course, different countries and organizations are developing their own approach to life cycle carbon assessment, right? So in your opinion, how do we avoid ending up with incompatible methodologies that make comparison between projects quite impossible? What's your opinion?
So at the product level and at the building level, I think the methodology is now reasonably standardized, and the UK methodology at the building level is informed by EU standard and it follows EU standards. That methodology now in the UK is very much getting widely adopted. So the RICS methodology at the whole building level. And at the product level, again, we try to follow within the simplified approach the concepts of EPDs, where the next big headache for us at CIPSI in terms of alignment is the lack of product category rules. So that system boundary, basically, what do you count within an EPD? And in TM65 calculations, we're very keen, to the extent that we can, to align with EPD boundaries, but because these boundaries or product category rules are not well defined for MEP products, it's a bit of a nightmare, I'll be quite blunt. It matters less for TM65 calculations, I think, than for EPDs, because we only count at a higher level. We count the bigger things, but still, it's definitely the one where at the moment we get the most questions and the most debates. So we're trying to follow as many initiatives as we can. We're trying to build on as many initiatives as we can. In our embodied carbon group, there are people involved in European initiatives, in US initiatives. CIBSI is based in the UK, but a third of our members are worldwide, so we really try to capitalize on that. But yes, MEP is complicated. It comes from all over the world. It moves 100 times before it gets to your building, so it's quite complicated to assess.
Absolutely.
I'll quickly, I know we're converging a time. I think I saw this lovely life cycle diagram about the carbon management framework, and I found interesting. I don't remember all the headings, but it has like different aspects about how to develop a consistent and compatible methodologies. One is obvious working group that we're working combined with policymakers, engineers, consultants, embodied carbon specialists to develop the methodology itself. But also there are different elements. One part I saw is about thought leadership. Platform that through Euroheat Power, through CIBSI from Europe is exactly to speak up, saying, look out, this is what we're talking about. Those are the questions to collate at early stages as well. The reason I remember that was that, that's what I'm going to do tomorrow about promote. And I think there is no better way. And this has been the challenge across all the new policy guidance methodologies. And I think the only way is to work together collaboratively across disciplines, across regions, and platforms like this will be brilliant to hear all the feedbacks and the working groups that I'm keen to join.
Absolutely, Xiaofang. I couldn't agree more. I think part of our job is also to promote this discussion. It's also the aim of these kind of webinars to present these great works you're doing and how the industry could support. Of course, it's not just we supporting the industry, but also industry supporting us. And yes. So my last question is more on the policy side. It's very quickly. So we said we need collaboration across industry to build data set, benchmarks, so on. So, in your opinion, what incentives are needed for manufacturers and utility to share the data that they are often commercially sensitive? It's something that is not just for this kind of analysis, but in general, so for digitalization, the sensitiveness of data, confidentiality, it's a problem. So, in your opinion, maybe there's no any right answer, but in your opinion, which are the best incentives to let them share this data?
Do you, yeah, okay. I'm not carbon specialist, but from my kind of thinking, we have been through this process from an operational carbon perspective. I don't know, in the past, 20 years ago, is carbon a key driver? Is operational carbon a key driver to pursue the low carbon solutions? I don't think so, from my personal experience. How the policy, obviously, incentive is different. There's carbon offset funding. There are S106 in the UK. They're kind of different mechanisms. And what we are talking about for operational carbon, embodied carbon doesn't differ significantly. It's taking into consideration of the whole picture and ensure fair comparison across systems, but not creating anything new from my perspective. It's about evaluating whole life carbon rather than operational carbon. And there are, initiatives about financial carbon trading platforms. I know it went through, that's something I heard from colleagues, I have to say, but those kind of topics are very active. And which direction it takes us to, I don't know. But again, can you hear?
I think what I would add is that, so from a policy perspective in Europe, you're much more lucky. There's more and more, there's a clear direction towards assessment and ultimately regulation of embodied carbon from buildings. We are not there yet in the UK, and CIBSI support a campaign for the regulation of embodied carbon, but there is no doubt that until assessments are required in regulation, there is less of a driver. However, what we are seeing from a CIBSI perspective is that a lot of manufacturers are very willing to share their data in order to be on the CIBSI register or database of products. So that would be essentially quite a big incentive we're hoping for. Then what level of data they share is quite dependent on manufacturers. So some are quite willing to share everything behind the TM65 calculation, i.e. how much of the breakdown of materials, where it was manufactured, while others are more sensitive about, for example, the location of their factories. That was quite interesting for us to find out. And they are more, and others on the extreme end just want to share the embodied carbon result of the product. We're hoping that more and more we will be able to provide incentives to show as much information as possible. There's also different levels of sharing. For example, for CIBSI, for benchmark purposes, we don't necessarily need to say what manufacturer's product it is. What's quite important is, for example, there are heat pumps which use so much less material than others. That kind of information is useful in itself for manufacturers. So maybe another incentive we're thinking about is if you want to see where your product fare against others, then you need to share your information. Otherwise, we will not. So that kind of things we're exploring.
Thank you, Julie. So that was my last question. Thank you, Xiaofang. Thank you, Julie, for this very insightful, interesting presentation. Present a very useful, methodology. Thank you again. And of course, the DHC Plus webinar series is not ended here. So stay tuned for the next episode. Will be on digitalization. The title is From Design to Optimization, Digital Intelligence for Next Generation in Networks on the 16th of Monday, of March. It's a Monday. Then, of course, we have another important appointment on the 9th and 11th of June 2026. We have our European Power Congress, the biggest district heating related event in Europe with more than 500 participants, 25 sessions, and of course, a lot of different topics to speak about. So I really invite you to register both to the webinar and, of course, to the Congress. I look forward to meeting you there. Thank you again, Julie. Thank you, Xiaofang. Thank you for the technical support. And see you at the next episode. Have a great day. Bye-bye.
You too. Thank you for hosting. Bye.
Thank you very much.
Bye-bye.